All right, so in this lesson, we're going to talk about graphing linear equations using the y equals mx plus b slope-intercept form. And we're going to be doing it from the equation to the graph. So basically reading the equation so we can graph it. And we're going to read the graph to get the equation, okay? So it's basically using the same skills, just going back and forth and reading different things for the same information. Just using the information a little different. So what I mean by that is, for example, in number 1, y equals negative x plus 3, you recognize that the slope, or the m, which is always the coefficient of the x, is negative 1. And we know that because there's a 1 in front of the x that's not written. And so that's where the negative 1 comes from. And the b, or the y-intercept, is going to be 3, because that's the term that doesn't have the x, and it's a positive 3, so that's how we know it's 3. Now if you remember, like we said, our slope in the previous lesson, we count our slope using rise over run. And the rise is the vertical change, and the run is the horizontal change. Okay, and we're going to use the vertical change and the horizontal change between different points that we're going to, and the y-intercept is your b value. Okay, so, and the y-intercept is where it crosses the y-axis. All right, and I like to think of it alphabetically. Since b comes before m, we're going to first plot our y-intercept on the y-axis, okay? I'll talk about step 1 in a second, because if it's in y equals mx plus b, like this first page, except for these two, so 1 through 9 on the first page, it's already sloping. We don't even have to do step 1. But if you notice step like 10, 11, and then 12 through 21, these are not in slope-intercept form, okay? These are in standard form. So you would have to, step 1, do what we did in the last lesson and solve for y, so you then can read the m and the b. Because we have to, this is the only readable form. And when I say readable form, it's because we can directly read the m for our slope in front of the x and the b for our y-intercept, okay? So like in number 1, so again, like I said, alphabetically, the b comes before the m. So we start with the b, which is the y-intercept. So I go to positive 3, boom. The slope, we're going to use the slope in both directions. What I mean by that is the equivalent slopes that we talked about in the slope lesson, the first slope lesson, okay? Now, because slope is rise over run, we need to make sure we have a fraction and so we can read the rise separate from the run. And what I mean by the equivalent slopes, remember we talked about a negative divided by a positive is the same thing as a positive divided by a negative. It's just going to change the directions, but we need to have the correct directions so they stay equivalent. Because we know a negative divided by a positive is negative, and a positive divided by a negative is also negative. So we know the slope's going to be going down, okay? So now if I use the first slope from the y-intercept, the negative 1 in the numerator says go down 1. The positive 1 in the denominator says go right 1. Boom, you plot your point after you do both the rise and the run. We go back to kind of the home base, which is your b, your y-intercept. Now let's do the other slope. The positive 1 means I go up 1. Sorry, the positive 1 in the numerator means I go up 1. The negative 1 in the denominator says go left 1. And notice how these points line up? That's what should happen. And then overall, it should be going down, like we said, a negative slope, and it fits, okay? Now, let's try number 3. So if your your b, if your slope is 2/5 and your b is 2, and if we start with our b, think alphabetically, which crosses the y-axis at positive 2, okay? And then we know a positive over a positive slope is equivalent to a negative over a negative slope. So I'm going to use these two slopes from the y-intercept. Okay, that's step 2. Step 2 is plotting the b. on the y-axis. Step 3 is you use the slope to create more points. So that's what we're doing. We're using our equivalent slopes. Okay? And we know a positive divided by positive is positive, and we know a negative divided by a negative is positive. So if we graph these in the correct rise over run directions, we'll have the points line up. Okay? So from here, I'm going to use the first slope. So positive 2 for my rise and positive 5 for my run brings me to this point. Negative 2 for the rise means I go down 2, and negative 5 for the run means I go left 5. And notice they all line up, which is exactly what I want. Okay, there's your line. And we know that it's a straight line connecting the points because notice here the x and the y, they don't give you any restrictions, so we know the domain is all real numbers. Okay, a little detail, we'll get more into that later. Okay. So let's try, I want to look at, okay, number 7. Now notice our m is the number in front of the x, and you might, again, if there's no number written, it's a 1, right? Because we just don't write the 1 in front because it's too, I guess, trivial. But the y-intercept, the b, is -4, okay, because of the -4. The sign with your b value tells you whether it's positive or negative, okay? So first thing, let's plot the -4. Boom. There's our y-intercept. Our slope. Well, we need to see the rise over the run, so we need to change this into 1 over 1. So we can see the rise and the run separate. And we know that 2 positives is equivalent to 2 negatives when we divide, okay? So let's do the first slope where we go up 1 over 1. Boom, there's our point. The equivalent slope back to our home base, which is the y-intercept, let's go down 1, left 1. And then you just connect your points, okay? Now let's look at number 9. We know the m is 4 because that's the coefficient or the number in front of x. But notice, what is being added? What's the b? Well, guess what? We can add 0 and nothing changes the value of 4x. So in fact, our b value is 0. And anytime the b value is 0, that means it crosses at the origin, okay? So we already have our y-intercept graphed, so let's go back to our slope. We know that we need a rise and a run, so we have to put it in fraction form. We also know 2 positives is equivalent to 2 negatives in division. Oops, almost wrote -4, but that's -1. So let's use the first slope, the 2 positives. So from our y-intercept, we go up 4, right 1. Let's go back to home base or our y-intercept. Let's go down 4, left 1. Boom. There's your line. Okay. Now, like we talked about, okay, I'm going to have you pause the video and do the problems. Okay, I'm going to have you pause the video and do the problems that Now let's look at the case where we have to do step 1. Okay, step 1, I'm going to go ahead and put comma if necessary. Because notice 1 through 9, it wasn't necessary. Okay, so if we do 10 through 21, all of these, they're in standard form, where the x and the y's are on the same side. So we need to solve for y like we did in the previous lesson to get it into the y equals mx plus b. So that's our first step. But then we do exactly what we did for all of these, okay? So like on number 10, first thing, we always eliminate our x term. So let's subtract x on both sides. So we get 2y equals, and we always put the x term first, negative x, and since 4 is positive, we do plus 4. Now we have to divide by 2, and we have to remember to distribute that division. Now we just reduce everything. So this 2's divide out to get 1y or just y. So y equals, I was saying, since we have The negative x means negative 1x. And remember, we want the rise and the run for the slope, so it's negative 1/2 x. And then 4 over 2 just reduces to 2. So we know our slope is negative 1/2 and our y-intercept is 2. So we start with our y-intercept, positive 2, and we know our slope is negative 1/2, which a negative is either a negative over a positive or a positive over a negative. And we're going to do both from the y-intercept. So first we're going to do the negative 1, so down 1, over positive 2, which is right 2, and then go back to the y-intercept. To do the positive 1 over negative 2, well, positive 1 means up, negative 2 means left 2, and then all the points line up, so there we go. Okay. So let's look at number 11. So again, first thing, we subtract our x term, okay, or eliminate. Be careful with the sign on the y. Don't drop the sign on the y. Like over here, it was positive 2y, so that's why we had the positive 2y. Here it's a negative 2y, so we have a negative 2y. Don't drop your negative, because that will completely change the slope and the y-intercept. Okay, so here we have our negative 3x and our minus 6. We divide by negative 2, and notice when we divide by a negative, it's going to change all these signs, and so you get y equals positive 3 over 2x, and then a negative over a negative becomes a positive. 6 divided by 2 is 3. So our slope is 3/2, and I'm just going to go ahead. We actually have the equivalent slope right here, so negative 3 over negative 2, and we know our b value is positive 3. So we go ahead and plot our point, so up to positive 3, and then let's use the positive slope first, the positive over positive. And notice if I go 3, I'm off the graph. Not a big deal. I just extend the graph however many units I need. So I'm going to go up 1, 2, 3, but then I'm also going to go right 2. So then right 1, 2. Boom. I almost went the wrong direction. And then for the negative 3 over negative 2, because we know 2 negatives divide to a positive, we go down 3 and right 2 from our y-intercept. And then here we just go ahead and plot our points. Or, sorry, draw on the line for the points we plotted. Okay. So on this page, I want to look at a couple ones in particular, like number 13. Okay, and we've covered this in the warm-up, but I just want to make sure that you guys understand this, because this is a common mistake. First step, everybody usually gets this right. So you subtract the 5x. Okay. We have our negative y. Don't drop that negative like the previous example. Okay. We rewrite this as negative 5x minus 5. Some people stop there, or they drop the negative thinking it's not important. It is important. This is where math gets really, really picky, and the details make all the difference. Okay, and we can't change that. It's just the reality of math. Okay, it's really, really picky. Remember that negative y, that means negative 1y. We still have to divide, because for the formula, we need a positive 1y. Okay, that's what y equals mx plus b means. We have a positive 1y. So when we divide by the negative 1, we get y equals, this becomes a positive. And since I know I'm graphing, I'm going to keep it as 5 over 1, since I'm going to use it anyways as a fraction for the rise and the run. And then over here, the negative 5 divided by negative 1 is positive 5. So real quick, I'm just going to write down my slope is 5 over 1, which we know is equivalent to the 2 negatives, which I already have in the previous step. Now the y-intercept, our b value, is positive 5. So right away, I'm going to go up to positive 5. Now notice, if I go up 5, I don't have any more graph. Well, no big deal. Just continue your y-intercept and just make your best effort, or, you know, hash marks, so we can go up 1, 2, 3, 4, 5, and write 1. Then we go back to our y-intercept and we can do the 2 negatives. So down 1, 2, 3, 4, 5, because the numerator was negative 5, and left 1 because the denominator was negative 1 for the equivalent slope on this one. And then we draw our line. Okay. Now, if you're on a test and you're short for time, I'm okay if you just do the negative slope and then draw the line instead of doing all this part. I'm okay with that, but you need to know both. Okay. Now, the other one I wanted to look at was number 19 and then also number 21. So with number 19, oh wait, no, I'm sorry, I want to do 16 and 19 and 21. Okay, a couple things I want to point out. So in number 16, when we subtract the x on both sides, okay, we get our 3y equals negative x minus 3. Same as our previous steps, okay, now we divide everything by 3. One of the common mistakes that I'm noticing from the last lesson's warm-up, a lot of people are giving me 3x when they see a negative x over 3 or some other number, okay? But be careful. Remember we said, what does a negative x mean? It means a negative 1x, okay? Negative 1 is in the numerator, 3 is in the denominator. Negative 1 over 3 is not 3. Let me prove it to you using a calculator, okay? If I do, we always know a fraction is top divided by the bottom. So if I do, I hope you can see it on the negative 1 divided by 3, I'm not going to get 3. Guess what I'm going to get? Negative 0.3 repeating, which is negative 1/3. Well, that's exactly what this is. All we do is preserve the numerator and the denominator, which is negative 1/3. Just pull out the x so we can see the m separate from the x, and then we go ahead and just reduce. Negative 3 divided by 3 is negative 1. So we know our slope is negative 1/3, which a negative over a positive is equivalent to a positive over a negative, and our b value is negative 1. So we're going to graph our b value, negative 1. We're going to go for this first slope, down 1, right 3, and then back to home base. Now the second equivalent slope, we're going to go up 1, left 3. Okay. Now look at number 19. We need to subtract the 10x on both sides. Same thing, we always get rid of the x term first or eliminate the x term. We're going to preserve that negative 8y equals negative 10x plus 24. We're going to divide everything by negative 8. Okay. Now we get y equals, we know a negative divided by negative will reduce to a positive, but some people are like, well, 8 doesn't go into 10. No, but don't forget, you do need to reduce it. And frankly, you won't want to be making 8 and 10 extra little markings, okay? Reducing is always your friend, okay? So this ends up being positive 5 over 4x, and then 24 divided by negative 8 is going to be negative 3. So our slope is our y-intercept is negative 3. I'm kind of rushing because I feel like at this point you guys know how to read the m and the b, and if not, please bring it to my attention in class. And then we can go up 5 over 4. And at this point, going the two negatives, I'm not going to do right now. We get the picture. 2 points is actually the minimum you need, okay? And there's our line. And again, it should make sense. We know the slope is a positive 5/4, so positive we know is increasing from left to right. So that works. We didn't forget a negative somewhere. That's always a good check. Now look at number 21. So if I eliminate my 3x on both sides. Now you could write this as y equals negative 3x and not write the plus 0. But for now, just do the plus 0 because there's some people without the plus 0 get confused and stuck and think, well, there's no b. So they kind of get discombobulated and it's freak out that they don't understand this. The point is, the b is the 0, which we said is anytime the y-intercept is 0, it's at the origin, okay? And then we can go ahead and use, remember our slopes, so negative 3 we write as negative 3 over 1 or 3 over negative 1, okay? And I'll just write out Might as well write out the b if I wrote out the m. So let's do the first one. Well, -3 positive over 1, and go back to the origin or their y-intercept. 3 over -1, we go up 3, left 1. There's our equation. Okay. I want you to pause the video and do these other problems and check to see if A, are you solving for y correctly? Because if you don't do that, you're not going to be able to read your y. You're not going to be able to read your slope and your y-intercept, and your graph's going to be wrong. Okay? And make sure that even if you solve for y correctly, are you graphing it right? Are you doing the correct y-intercept? Are you using the correct equivalent slopes and the correct directions for your rise and your run according to the signs? Remember, it's very picky, very detailed. Okay, so pause the video, check that, and then we'll go to the last part of the lesson. Last part of the lesson, now we're doing the opposite. We have the graph, and all we need to do is read the m by counting rise over run, and read the b, which is just basically naming the y value where it crosses the y-axis or the y-intercept. So we can do it, honestly, step 1, step 2, like it says identify the slope, which I'm going to say m, and with the rise over run, and the y-intercept, which I'm going to put as the b. And then step 2, write the equation in slope-intercept form. So basically you're just plugging in your m, and just make sure the m is reduced all the way, okay? So make sure your m is reduced. And then the y-intercept, the sign tells you whether it's plus or minus, but the formula just states it's y equals mx plus b. So like in number 1, I honestly like to do the b first. That's just my preference. You may not like that. You may want to do the m first. It doesn't matter. I notice that it's crossing at this point, which from the origin is -3. So our y-intercept is -3. And then I can see between these 2 points, I would have to rise 3 and run 1 to the right. So it's going to be 3 over 1, which is just 3. Because we want it simplified as like low as possible. And this is a situation, the final answer, if it isn't a fraction, we want it reduced to the integer value. Okay, so it's kind of like the opposite. If we already have the graph, we don't need the rise over the run if it's not already a fraction. Okay, so in this case, I'm just going to plug in the m. We have y equals 3x, and then plug in the b, which is -3. Boom, there's our equation. Okay, so let's look at, okay, so number 2. My preference is to do the b first, and we notice it crosses the y-axis at +2, and then I know I'm going to have to go down and then right, so I have -3 over +2, which I can't reduce that any further. Reducing is not the same thing as changing to a mixed number. Okay, reducing means there's nothing more I can divide out the 3 and the 2 because there's no more common factors other than 1. Because dividing out 1 doesn't mean anything. So we're just going to write it and plug in our m and our b. We have y equals -3 over 2x plus 2. I feel like this is almost quicker than what we previously did. I'm going to have you do these on your own, but real quick, there's on the second page. Okay, I want to look at number 11 real quick because I feel like the rest you can do on your own. Remember, we need the m and the b so we can write the equation for all of these, even though they didn't give you the space this time. So if I start with the b, because that's what I'm comfortable with, notice it crosses the origin. So remember, that's going to be 0. I'm still going to count the slope, and I see that I have to go down 3 and right 3. So I have a -3 in the numerator and a +3 in the denominator. Well, to reduce that, -3 divided by 3 is -1. And so when I plug that in, y equals -1x, I just write it as negative x, and then I can write plus b. Well, plus 0, I don't even have to write. So this is my final equation. If that didn't make sense, okay, let me show you what that, so if I just plug it straight in without simplifying, y equals negative 1x plus 0 for the m and the b. But remember, we don't have to write negative 1x. We don't have to write, we just write it as negative x. And we don't have to write the plus 0, so we don't. This is the most correct. Nothing's wrong with this. It's just not as higher level thinking or sophisticated or showing mastery level. Okay, the y equals negative x is the mastery level equation or understanding. Okay, now